this is a good time to review the difference between intrinsic and extrinsic properties. So let's make sure we remember intrinsic and extrinsic. Wow, okay. Intrinsic, extrinsic. So intrinsic depends on sort of the material only, if we're talking about material properties. And extrinsic, again, talking about material properties, depends on material and size, shape, mass, etc., amount. Okay. So the best example, if you want to compare just in your head, is density is an intrinsic property. Density is just the amount of mass per unit volume, whereas if you actually had an object, it has it has an actual mass, right? So this does depend on the density, but also on how big it is, what's its volume. So its density times its volume would give you its mass. So there's actually 4 quantities to throw around when you're thinking about resistivity. So I want to make sure it's clear the difference. The first one we did was an intrinsic property. It was the conductivity. Okay, the conductivity sigma, and it was in 1 over ohm meters. So that's how Ohm's law is stated. It's stated in terms of an intrinsic property of the material. We also use that to get to the resistance. All right. The resistance was R in ohms. And the resistance of a wire is really an extrinsic property. It depends on what kind of wire it is. It depends on the conductivity of the wire, but it also depends, remember it had the length in there and the area in there. The longer the wire is, the higher its resistance. That kind of makes sense. The bigger the cross-sectional area, the lower its resistance. And that kind of makes sense. More places for the current to go. So these are the 2 we've talked about, but they're not the inverse of each other, actually. So there's 2 more that we could define. One would be, if we have a resistance, an object must have a conductance. Okay, that's usually G, and it's actually in a silly unit. It's inverse ohms. It's called mhos. You don't see it too often, but it is in mhos, or you could write it as ohm to the -1. So if these are the inverse of each other, there must be an inverse of conductivity, and there is. It's the resistivity. And the resistivity, we usually write, you're going to hate this, with rho. So this is not the surface charge density, and this is not the volume charge density. This is the conductivity in this case, and this is the resistivity of the material. So these are inverse of each other. Rho equals 1 over sigma. They're really the same thing. There's no difference. It's just whether you want to think about it as conductance or resistance. And these are also the inverse of each other. R equals 1 over G. Now when we do problems, so especially in freshman physics, we almost never use this. This is pretty rare. We won't think about that. We'll think about resistance. And then when you're calculating resistance, you'll look up a table for the properties of the material, and half the time it'll give you conductivity, half the time it'll give you resistivity. But there's no difference in the information. You just got to invert it or not. All right? So there's 4 actual terms. Keep them all straight in your head. 2 are intrinsic, the ivides are intrinsic, and the anses are extrinsic.